So I'm going to pull a little bit of an audible, which in football terms meaning change the deck around at the last minute. Possibly not the best audience for a football metaphor, but we'll go with it nonetheless. So I'll share some of my story, which is illustrative of the opportunity in agriculture and farming, as well as what the pain points are. So I joined. I'm a farmer, which my wife laughs at when I say, but at AeroFarms, we're farmers. We grow and sell leafy green products. Think spinach, kale, arugula. We've grown over 200 different types of short stem green plants. And we are, historically, we were a technology company. We're farmers, a technology company. And today, we're really the intersection of technology and engineering, like mechanical engineering. We have structural engineers, mechanical engineers, lighting engineers, electrical engineers, meets horticulturalists, meets data scientists. So how do we perfect taste, texture, yield, nutrition? And I started here because when I founded another company, a nanotech company, and when that company was sold, I was trying to figure out what to do. I had a passion in the environment. I got involved in some environmental causes, and one of which I was, for example, on the Global Agenda Council of Water Security for the World Economic Forum. And one of the aha moments for me was seeing where a lot of water gets polluted and used, and that's farming, agriculture. So in the US, for example, about 70% of our fresh water goes to agriculture. So a huge number. That was eye-opening. Equally, about 70% of our freshwater contamination comes from agriculture. Think pesticides, herbicides, fungicides. We over-fertilize our water. We have like this flood irrigation systems, and it leads to river runoff, which leads to algae blooms, which leads to dead zones, which leads to dead fish and contaminated water. So it became clear if you want to help solve the world's water problem, look at agriculture. So then I kind of looked at trends in agriculture, and one of the trends was local food production. And this looked like a trend, not a fad. And then as a technology enthusiast, kind of looked to see like where there could be a technology differentiator that could be transformational in the space. And I came together with a couple friends, one who's here, Mark Oshima, who is in the audience someplace. Mark, where are you? There, Mark. So Mark, who led marketing at Food Emporium in Citarella, and was a good friend of mine, is a good friend of mine. So we came together, partnered up to build a company focused on local food production, on vertical farming. First, we were looking at hydroponic farming, and then we realized that transformational, and I didn't want to do something that was incrementally better. I wanted to do something that was transformationally better. And we brought in another two people, some engineers, and we spent about 7 months looking at like what technologies are out there that could be a foundation to go much further. And we basically merged with a company that was out there since 2004 called AeroFarms. AeroFarms came from the Cornell School of Agriculture. For those who don't know, Cornell is one of the leading schools of agriculture in the world. And what they've created a foundation of, this professor at Harvard that we've built upon was a system. And net today, we could take a seed and grow that seed in 16 days. In another 12 months, we're going to average 12 days. That's otherwise takes 30 days in the field. So here, just using a non-GMO seed, it could be an organic or just a regular non-GMO seed, grow it in literally half as much time, if not less. And that's just giving the plant what it wants, when it wants it, how it wants it. So people say, well, don't plants need sun and CO2? Yes, but they don't need sun, actually. They actually need spectrum. So we're able to be very efficient with the plant and say, not only what spectrum do they need, what do they not need? And take away some of the spectrum they don't need. That helps save on energy and also makes the plant more efficient. That could kind of get pests to move away. So you don't need pesticides, herbicides, fungicides. And what do they need? Same thing with nutrition. So when you think of what the plants need, so people would say, don't they need soil? So we grow without soil, without sun. And plants don't need soil. They need minerals, elements, salts. So when you think of what a plant absorbs from its root structure, it takes up nutrients from the soil and supplemental nutrients called fertilizer that are put on. And we could kind of understand what different plants want, take a cross-section, and break it down to those mineral and elements. And it usually comes out to about 20 different products. And we don't just put them in as one big glop, but that's a scientific word, by the way. We put it in individually. So what are those minerals, elements that go in individually? And then we have sensors all over that, and we have our own PLCs, program logic controls, that understand. We have what's going on in the farm system that take counts like every day of what the root structure absorbs, and then course correct those minerals and elements. So we're just perfecting what the plant wants. Same thing with CO2, same thing with O2, same thing with temperature, pH, humidity, everything the plant wants, so we could optimize the growing conditions. And this is a food conference, so the net impact is great tasting, quality, clean food. So when you read a package and it says triple washed, and you think well, usually we don't think in terms of why we're triple washing and what's important, but we don't want those chemicals. We don't want that residue on the leaves. And this is taking those chemicals and not putting in any pesticides, herbicides, fungicides, so giving a very clean experience to the consumer. And the fertilizers are, I mentioned, no soil, so our growth media is a cloth. And the fertilizers are all barriered by that cloth. So the fertilizers and the nutrients, in our case, these minerals and elements that we're putting in are all just misted. So we're called AeroFarms. The aero is in air. So the root structure wants O2, oxygen. So we oxygenate the roots by misting nutrition to the roots. The leaf structure wants carbon dioxide, so we put in supplemental CO2 at the leaves that we blow in. That enables the fertilizers just to be kept at the root structure, and again, the leaves being very pristine and no pesticides. So we figured out what spectrum of light the pests use to see, and we stripped that out. So now the pests are like blind to the plants, so that's like another way of pest control without the pesticides, which is pretty cool. From a performance standpoint, I mentioned we're able to grow in 16 days versus 30. We're also able to do that using 95% less water. So this whole flood irrigation system is really antiquated. And just as a sidebar, but one of the things we can do as a society to be more water conscientious is to price water towards market rates. Water is artificially low, and we don't need to say, water at our homes are going to go up. We could say water for agriculture, water for industry could go up. So then people use smarter forms of irrigating, which today isn't necessarily the case. Right now, a farmer, for example, might pay to water a field of a certain size as a flat rate. So what incentive is there to be smart irrigators? And there's also sometimes policies of use it or lose it. So if you don't use the water, you lose it for the next year. And right now, the salad bowl in the US, 95% of our greens are in Northern California. And most of us know there are huge droughts in Northern California. So additionally, like huge energy costs to pump water from the Colorado River to Northern California. So anyway, big systematic changes need to occur. So here, back to AeroFarms, we could take this same seed and grow it with 95% less water. And again, 70% of our fresh water goes to agriculture. So there's big opportunities, technological opportunities to change the paradigm there. Additionally, I mentioned 70% of our freshwater contamination comes from agriculture. So there, too, we have a fully enclosed system. So our system, I mentioned, we miss nutrition to the root structure. What the roots don't absorb just goes right back down in a fully contained system and gets misted again. So it's a continuous cycle in a closed-loop system. From a food standpoint, so not only do you not have to wash the product, and a lot of food contamination, another reason why we focused on leafy greens is some of the highest rates of food contamination. Think Salmonella, E. coli, Listeria, and so forth. So here, a lot of that contamination spreads in the washing process. So if we don't have to wash, we've just de-risked that spread of these sort of viruses and bacteria. So that's a good thing. From a nutrition standpoint, we can actually influence the nutritional density of products. So sometimes people say, what's the nutritional profile? It's the same seed. We're giving the same materials the plant wants, just a different way. And we could actually influence. So for example, there's a growing trend in functional food. Antioxidants, for example. People want a higher antioxidant experience of a product. When you think antioxidants, there's a chemical going on where if a plant needs to trigger its defense mechanism, it produces more antioxidants. We could stress a plant different ways to get it to produce more antioxidants. So then you have a higher antioxidant kale or spinach or arugula. So increase the nutritional density different ways, but again, giving the plant what it wants when it wants it. So I started off saying we're like engineering meets horticulture meets data science, and that intersection is really important because it's also about taste, texture, yield, nutrition. So our team constantly works to optimize those elements: taste, texture, yield, nutrition. So taste and texture, the same way we're influencing the nutritional density, we're influencing taste and texture. So do you want a peppery arugula? Do you want a sweeter mitsuna? Do you want a crisper leaf, a softer leaf? That's the data science of what we do. What are the different levers? And we're fully controlled agriculture, so we have all these different levers to understand cause and effect and to optimize those items. So our horticulture team is just like loving the world. We have some really bright people that come from, whether it's greenhouses or the field, and from a person I spend most of my time hiring. And we're hiring like crazy, by the way. If people are interested, please visit our website or talk to Mark and me. And it's not just like the science team. We're kind of hiring in different areas. But is that a good pitch? On the nutritional side, so the guys who are the horticulturists, they're just like looking at the world in a way that horticulturists haven't looked at the world. They haven't really thought in terms of influencing these elements of taste, texture, yield, and nutrition in ways where they can control all these parameters. And it's also about choosing the right seed that grows in the right environment. And that conversation, by the way, with seed producers is different. We don't need to discuss about optimizing drought resistance or optimizing pest resistance. It's just not a factor in the way we grow. So anyway, so let's see if there's some cool photos to go along with this. We're a mission-driven business. We build and operate responsible farms throughout the world, enabling local production at scale to grow safe, nutritious, and delicious food. The scale is important to us. So we didn't set out this to create farms that service a lot of wealthy, 5–10% of the population. We wanted to produce product at scale that can feed mass populations. So our vision is to build farms at scale in cities. So there's a big trend in urbanization, so build big farms to service populations. And the economies of scale are important to make things affordable. So currently we're building the largest vertical farm in the world. That's in Newark, New Jersey. It's not necessarily economical to go to Fifth Avenue, or we heard Brooklyn real estate's going up. So Newark, New Jersey is still a lagger in that respect. So this is, being transparent, this is like a $30 million project, and it's going to be beautiful. It's going to start producing food later this year. And we're getting supporters, by the way. This is part of it, this project in Newark we're building. This is our headquarters as well as our R&D facilities. We got backing from Goldman Sachs and Prudential for this. So some of the big financial players are excited about the space and the opportunity to invest in the space. We've won some nice awards. Here's something cool we're doing. So one of the other kind of battles we're looking to fight is urban obesity. So huge problems in this country with urban obesity, and childhood nutrition is key. So we put a farm in a school in Newark, And our productivity per square foot is 50 to 70 times that of a field farmer. To put that in comparison, like a greenhouse grower is typically about 6 times that of a field farmer. And the math is like we could take a seed, I mentioned, do it in 16 days versus 30 days. That's 30 days in a greenhouse or in the field. And I mentioned by the end of the year, it's probably going to be down to 12 days. So that plus multiple levels of growing, plus there's a lot of crop density, gets tremendous output in a small footprint. So here in a school in Newark, in about the footprint from the corner of the stage to about here, we put this in the cafeteria, K through 8th graders. The 6th graders run the farm, and it feeds about enough leafy greens for the whole school. So the kids, seed it, grow it, harvest it. They don't like that taste of arugula that adults might like because it's bitter, so we grow things like chervil for them, that sweet taste they like, and the kids are kind of socializing with the product, and it's becoming part of their habits. So instead of the fries, they're going for the greens, and it's having a wonderful impact. This gives you a kind of visualization of what's going on. So here's the oxygenation of the roots discussed, and then supplemental CO2 there. And this is like if you envision a big sort of tunnel, and the plants journey across. They are seeded on one side and harvested on the other. And this is another visualization. So we've built 7 of these already. Now the 8th one we're building is in Newark, New Jersey. We already have two systems in Newark, New Jersey. And this is it's kind of fun. It's in an old nightclub. That's where our headquarters are. So we had to get rid of some of the lights, but we're still having a good party. So given that this is a food conference, we have some nice images of food. So this is, like my partner Mark says, like healthy plants, healthy roots, healthy plants. So we grow on the cloth. The cloth's on a tray, and you can see the product over there and the root structure. And this is part of the party. So plants don't need most of the spectrum they don't need, so we give them the spectrum they want. So we have some sophisticated lights that kind of test what the spectrum they do want, and then we put in other lighting systems that are more cost effective. This just illustrates the nutritional density. We could increase that nutritional density of the product. And then what better than some nice photos? These are some microgreens. These are some baby arugula, baby romaine. We've grown baby kale. So we've grown over 200 different products I mentioned. And we've had some of the top chefs in the city and around the world come visit us and really be impressed. And one of the exciting points, I sort of got into this thinking our main value proposition is fresh food. Like over 50% of what comes off the farm gets spoiled, gets wasted. So you think of all the embodied water and nutrients and so forth and pollution that comes from farming, and then over 50% of it gets spoiled. It's because this sort of category, it's like we've all experienced buying product and it starts dying and gets slimy. So this category is it needs to be consumed fast, and it needs soft hand-holding. So here, what's exciting is not only is it fresh food, the value proposition, but it's the taste and the texture. So we've gotten huge accolades for the taste and the texture, and this is one area where we're constantly working to optimize. Baby Kametsuna, and with that, I'll leave it here. But anyway, thanks for giving me the opportunity to talk to everybody.